Welcome to this lectures room. We want to look at our topic under integration, the topic called integration of exponential function and integration of reciprocal of x. When I say reciprocal of x, I mean 1 over x. Please do stay tuned and enjoy the class. Exponential x it has its own expression, and its expression goes thus. Exponential x is the value that is given to be 1. It started from 1 plus x, that is 1 plus x plus s squared over 2 factorial plus s cubed over 3 factorial plus x raised to the power 4 over 4 factorial plus x raised to the power 5 over 5 factorial and so on, plus to infinity like that. That is the value of exponential x. Now, integration of exponential x, the x now, will be equal to, now, look at it from each level. Let it follow each step accordingly. This will be equal to x, integration of 1, that's a constant, 1 times x is x, plus x raised to the power of 1 plus 1, 2 over 2, plus x raised to the power of 3 over, what is the exponential over 2, this 2 here, into bracket 3, because this 3, that's 3 plus 1, that is the value we have here. Then 2 factorial, that is 2 times 1, that is 2, plus x raised to the power of 3 plus 1, 4, over that 4. What is the value of 3 factorial? That is 6. That's 3 times 2 times 1. Plus x raised to the power of 4 plus 1, 5 over 5. Multiply by what? 4 factorial is what? 4 times 3 times 2. 4 times 3, 12. 12 times 2 is 24. 24. Plus x raised to the power of 6 over, what is the value? 6 into bracket what? 5 times 4 times 3 times 2, that will be 120. That is the value of the factorial that we have here. Multiply by the expression that will be at the denominator of every exponential integration. This become x plus x squared over 2 plus s cubed over 6 plus x raised to the power 4 over 24 plus x raised to the power 5 over 120 plus x raised to the power 6 over all over 600. That is the meaning of this plus as long as possible, plus to infinity like that. That is the value of expression of exponential x, integration of it in that order. Now, I'm going to provide some exponential expression which we are going to look at how to simplify them. Stay tuned. Integration of exponential expression, I have it here. Let's look at some exponential expression, then we are going to integrate them. Take a note at this. If you have this exponential x, the x, if you are to integrate it, it becomes exponential x plus c. Don't forget that every integration expression must be added to it the constant. If you have this minus x, the x, this will be equal to minus exponential minus x plus c. That is this expression, the way it's going to give. How does this one mean? Okay, let me simplify this for you. We have this. I cannot say let u equal to minus x. This particular value that is here, because it is not just x. So let u is equal to minus x. I cannot say that the x is equal to minus 1 by differentiating this expression here. Then what I will do next here is make the x subject of a formula. We are going to have minus the x is equal to what? Du. Then I can now say that the x is equal to what? Du over minus 1. Now, I can now bring this value of the x back here. Don't forget that I have turned this expression into what? Exponential of u. What's the value of this x now? Because minus x is taken to be u. What is the value of the x that I have here? That's du over minus 1. This minus 1 here is minus 1 is the same thing as exponential u du times minus 1 minus du. So which can as well become minus exponential u du. Now when you have exponential any value, a variable, exponential x dx, exponential u du, it's same thing as what? Exponential x. So it becomes minus, this is a negative value here, exponential u plus c, which eventually become what? Minus exponential, what is the u? Minus x plus c. That is that expression here. That is what we get here. So I try to simplify it to get it that way. Now I have another value here which I want to also find the value of its integration. Exponential ax. Ax dx. Exponential ax dx. Now in this case you can say let u equal to ax. The u dx will be equal to a. Don't forget that we are differentiating u and x, so is equal to a. So the x times a is equal to du, where the x will be equal to what? Du over a. Now coming back here, this one has become exponential. We have represented u by ax. U, what is the value of the x here now? Du over a, which is the same thing as exponential u du, exponential u du multiplied by 1 over a, which is going to be equal to 1 over a exponential u du. Now I have this exponential u du here, which is going to be equal to 1 over a exponential u plus c, which eventually becomes 1 over a exponential, what is the value of u? U is taken to be ax plus c. So that is the value of exponential ax dx. The same way you are going to solve as many as possible exponential expression. Let's look at some questions as regard evaluate this expression here. This is an exponential expression. So to us to evaluate it, we have to firstly take let 5x plus 2 equal to u. When 5x plus 2 is equal to u, don't forget that exponential x the x is equal to exponential x plus c. Take note of this. But because it is not just x that is the power here, that is why we have to make that particular value u. Then we can now say the u dx will be equal to, it's only this value we are going to differentiate. We are going to have it to become 5. This one is a constant, and don't forget differentiation of a constant is equal to 0. Is equal to 5. Then we can now say that from here this one is over 1. Cross multiplication, we have the x times 5 is equal to the u times 1. That's the u. There the x will be equal to the u over 5. Now, I want taken this expression here as u. Then this expression here can become exponential u dx. Now, substituting the x here, substitute the x into this expression here, we are going to have exponential u What's the value of the x that we make here? Du over 5, which is going to be equal to exponential u du multiplied by 1 over 5. And then it becomes 1 over 5 exponential u du. Don't forget, we have been able to achieve our exponential u du, which is likewise to exponential x dx. So we can now say that 1 over 5 exponential u integral du will be equal to 1 over 5 exponential. What is the value of our u? That's 5x plus 2. 5x plus 2 plus c. 5x plus 2 plus c. So that is the integration of this expression. I would like you to stay tuned for the next question. Integration of reciprocal of x. The reciprocal of x is 1 over x, and the integration of such expression is given as 1 over x dx will be equal to log x base e plus c. Now, don't forget that that is the expression that is going to, this expression is going to integrate into. And don't forget that differentiation of this as well is equal to 1 over x. This one has made it clear to us that the integration is the anti-differentiation. That is, the value we want to get in integration is the value that we are given as a question in differentiation. So let's take a look at a question to check whether this expression is real or not. We have the question here. The question says we have the integral value here, x squared over 2x raised to power 3 plus 3 dx. Solution to the question now. When you have this kind of expression like this, you look at the denominator. The denominator will be represented by a particular expression right now. We have let u equal to 2x cubed plus 3. So this denominator needs to be differentiated. Differentiating this one, we are going to have the u dx will be equal to 6x squared. Don't forget that differentiation of this constant 3 is 0. Differentiation of the constant is 0. So let's leave it that way. Then in this case now, we are going to make the x the subject of the formula. We're going to have the x multiplied by, this is over 1, by cross multiplication, multiplied by 6x squared is equal to the u times 1. Where we have the x is equal to the u over 6x squared. Now, this value we have here, and this value of u here, we need to be come into this expression here. We are going to have the integral of x squared over 2x cubed plus 3 is u, multiplied by, what is the value of the x? Du over 6x squared. X squared will cut x squared, making it to become 1 over u du over 6. This expression becomes 1 over 6 into integral of 1 over u du. This expression 1 over u du here has look like this. So it means that integrating this expression on this one becomes 1 over 6 that we have here multiplied by log u log eu, plus c. That is what we have there right now. Then what is that, Randy? What is the variable there? That is u. That u must be provided with its real value. We are going to have the expression becoming, we have started the integration from here. Once we have added the 6, there c, 1 over 6 log what is the value of u? 2x cubed 2x cubed plus 3 plus c. 1 over 6 log 2x cubed plus 3e plus c. That is the answer to that expression. Thanks for taking part of this class. Please do subscribe to our channel for day-to-day lectures from our channel. Thanks and God bless. See you next time.